we do here, we take our simulator as we have it, and we start to simulate objects that we want to classify or want to train our algorithm on. And for example, here you see these 3 objects. We put it in our simulator, so we model it in the simulator, and we just take pictures out of it. So what is the advantage? We don't need to label them because the software knows where an object is and what the object is, and we can put a lot of more variation in it. We don't have the bias of a person that is labeling, because we have also seen that in the past. The person who labels it, is always a very big bias that we have there. So you need different persons labeling the same things to get rid of that. So here with the simulator, we don't have that problem. So we have immediately labeled data, we have variation in our data, and we have we have already a very good start position to train our algorithms on. Technique here that we use is domain randomization. So what do? We take a setting, so we throw all these objects, for example, here in a bin, and then we start to do some things random. So we start to create some variation inside our environment. So what do? For example, we change colors, we change backgrounds, we change camera positions, lighting, all kinds of things we start to change, and that's in that way we can create a lot of big or huge data sets where we can then train all our algorithms on. And for example, and that's a very nice feature for in this small use case. We have only trained on synthetic data, so we have not used any real picture or any real object in our training data, and we have trained it on the synthetic data, and then we tried it on just with a real camera. We tried it real time to see how it works, and we saw that it's already immediately we had already very good results. Of course, you also see here at the end of the movie here, you see, for example, things that you haven't put in your randomization or your variation, it lacks. For example, here when you put the camera further away, that's something that we haven't put in our training sets or in our training data. And in that way, you see there that he starts to fail. So now, for example, here he fails, he cannot see the objects anymore because he hasn't seen that in his training set. So what do you need to do here is you need to do some iterations. You need to go through these data sets. You need to find the gaps in your data, and you need to retrain it. You need to put more variation into it, more colors, more textures, and these things. And you create, in fact, all kinds of situations that you could possibly have. But the nice thing is that you don't have the labeling effort, and you can create the data sets as big as you want, in fact. And we are convinced that you always need here the real data also, because some situations you just can't see, or you create a too big bias through synthetic data also. So a good mix of real data and synthetic data is here ideal, I would say.